These are relatively hard. These last couple here, but these are the last two problems of this section. They've broken up the non-calculator portion into a multiple choice, and then there's a grid section also.
Okay.
Let's look at number 14. Pretty sure we ended with 13, because I remember talking about that problem with you.
Okay. Okay. So if at 3x minus y equals 12, what is the value of 8x over 2y?
A little tricky. It involves a couple of things. First of all, let's solve for one of the variables. In other words, if we can solve for either x or y, then we can write this expression in one variable only, right?
Okay.
So let's try that. Which is the easiest variable to solve for?
Y.
Okay. So we got y equals 3x minus 12. Now we have 8 to the x over 2 to the 3x minus 12. And normally that wouldn't be that helpful, but in this particular, because we don't have the same base. In other words, it's only if we can make the same base that we can do something easy like subtract the exponents. Is there a way for me to write 8 and 2 with the same exponential base?
Multiply 2 by 4?
No, it's got to be, for example, 8 is 2 cubed. This is what I mean by the same exponential base, not a factor. In other words, if I gave you these two numbers, 27 and 9, what's the common exponential base between 27 and 9?
3.
Yeah, because I can write 27 as 3 cubed, and I can write 9 as 3 squared. So I'm not looking for factors, I'm looking for common exponential bases. Because now, when I can write 8 as a base of 2, now I can solve this problem. Because all I have to do is apply the rules of exponents. So what's the next thing I would write?
2 to the third.
2 to the 3x.
2 to the 3.
In other words, I'm going to multiply those two exponents because I'm doing double exponentiation.
Minus.
Or divided by. In other words, what we're writing is what I have circled over here.
Okay.
Okay. And I had 2 to the third to the x. Well, that's the same as 2 to the 3x.
Okay.
And now the denominator is 2 to the 3x minus 12. And now I have the same base, different exponents. What do I do when I have same base, different exponents?
Subtract the exponent.
What do you get?
You get negative 12. You get 12. 12.
2 to the 12. That's the answer.
Okay.
Okay. Let's look at 15. This one I struggled a little bit with this one. A lot of math involved in this problem. A lot of algebra.
If
Go ahead and read it.
Plus 2.
It's not even a good back-solving problem. You can't really go and check each answer and see if that makes sense. So it's definitely not a good back-solving problem, not a good problem for picking numbers because they put too many constraints on these variables. A plus B has to be 8. What's the only thing we can do to try to advance this problem?
To just try and work it out?
Well, let's multiply those two together. What do you get when you multiply AX plus 2 times BX plus 7? Let's go ahead and FOIL those. What do you get?
You get AX BX.
Well, you get, and when I multiply AX times BX, I get ABX squared. Okay, keep going.
ABX squared. Then you have AX, 7AX. 7AX. Then you have 2BX plus 14.
Okay. And they're telling us that that's equal to 15x squared plus cx plus 14. So now let's rearrange the left side a little bit. This is the part that's maybe the trickiest part of the problem. Let's combine those two middle terms like we typically do. When you multiply a binomial times a binomial, you usually get 4 terms and the middle two combine. Well, I can combine those. I've got ABX squared plus I'm going to factor out an x. So that coefficient is going to be this plus equals that. Okay. Now, we're well on our way towards solving it because they've also told us that A plus B equals 8. Well, what are some of the things we can say if this is true? If that is equal to that, what else can I say about A and B?
If that is equal to that, then it has to be...
What's A and B have to equal?
ABS equals 16?
15?
16.
Why are you saying 16?
Well, doesn't it depend on what you make A and B?
No. In other words, we know that when we multiplied those two monomial terms, or those two binomial terms, we got ABX squared. And this says 15x squared. So A times B must be 15.
Oh.
And C must be 7A plus 2B. And the third equation, we have 3 variables here, and there's a third that they gave us, A plus B equals 8. So there is a system of 3 separate equations and 3 unknowns. So I can solve that equation for C. How are we going to do it? There's no advantage of the multiple choices here, so let me expand this a little bit and let's solve this 3 equations and 3 unknowns. Not that hard to do. Let's start with the top one. Solve for either A or B.
Wait, so if we know A, B equals 15 and A plus B equals 8, doesn't it have to be 3 and 5?
If they're integers, yeah. And do they have to be integers? I don't know that we were told that they have to be integers.
Well, in the multiple choice answers, they all are.
Okay. Well, it turns out you're right. We can actually prove it. In other words, if I solve the first equation, I get 15 over A. And then if I substitute that in for down there, for B, I get A plus 15 over A equals 8. And when I solve this, it turns into a quadratic, and I get A can be equal to 3 or 5.
Right.
Which is what you surmised. And in fact, the way you did it is probably the better way because it's quicker, rather than trying to determine whether that's the only solution there is or not. But it's true. A can be 3, B can be 5, but also A can be 5 and B can be 3.
Right, they're interchangeable.
Actually 2 solutions, but you're right. 3 and 5 have to be A and B in one manner or another. And now, once we've determined that, what is one possible solution for C?
One possible solution for C?
Yeah, because there's 2 possible answers for A and 2 for B. In other words, A can either be 3 or 5, and B can be 3 or 5, or 5 or 3.
31?
Yeah, 31 when A is 3, but when A is 5, we get 41. Once you came up with the first one, you're home free.
Okay.
So actually, if this was just like a 20-second problem, you would have probably done fine on it. Because you didn't actually have to come up with both of these numbers. You only had to come up with the 31, and that told you which answer it had to be.
Right.
Maybe the hard part on this problem that you weren't really aware of was that when you have this top line here, let's scroll down and look at this top line. In other words, if I tell you, I got to put it higher because I erased the square. There it is. In other words, if I say this quadratic is equal to this quadratic, then you know that A times B has to be 15, and that this coefficient has to be C. That's the key to this problem, is knowing that. Once you know that, then you can solve it relatively easy. Relatively. I still think that was perhaps one of the harder problems. All right, now still non-calculator. So there's 15 questions of non-calculator multiple choice. And then there's 5 questions where you have to grid. Have you done one of these tests before where you had to grid?
Yeah, when I took the SAT, they made me grid.
Okay. So you know the ins and outs of gridding.
Yeah.
Okay. We don't need to talk about that then. Let's go down and look at some of these problems. If t squared minus 4 is equal to the 0, what is the value of t? Oh, and t is greater than 0.
So t squared minus 4 equals 0 plus 4. 1 second. The 2?
Yeah. But you only accidentally got that right.
Why?
Well, solve this equation. What's t?
2.
It's actually plus or minus 2.
Oh.
But
it said it had to be greater than 0.
Right. So we can throw out the minus. That's why I say you got it accidentally. But maybe not. Maybe you incorporated that into it.
No, I didn't, but you were right, but...
Okay. Let me suggest there's one different way to solve this quadratic, which I think is better because 90% of my students leave out the plus or minus. They really do. And in this problem, it didn't matter. Okay? But there could be problems where it really will matter, where you need the plus and the minus. Well, let me show you how you'll never make the mistake. look at that as difference of perfect squares, which factors like this. And now you get both solutions. You get t equal 2 or t equal minus 2. In other words, when you treat these as difference of perfect squares, you never make a mistake.
Okay.
And I don't mean you, I mean anybody.
Anybody.
Yeah. Now, if you're somebody who always remembers that if t squared equals 4, t is equal to plus or minus 4, you can do it that way. It's actually maybe a little quicker. I don't know. It's really any quicker.
I always forget, so.
All right, let's look at 17. I'm not sure why 17, they don't just label the picture. I mean, there must be a reason for it. But anyway.
Summer champions. Okay.
I will label the picture. AB is 1800.
So.
EB is 1400. BD is 700. And CD is 800. And this angle is the same as that angle. And we're trying to solve for x.
Okay.
What kind of triangles are these?
What kind of, they're, equiangular?
Correct, which means they're what kind of triangles? If they all have the same angles, in other words,
They're similar.
yeah, we know that angle's the same as that because they're vertical angles. And if this one's the same as that, well, then this one has to be the same as this. Okay.
Okay, so you just set up a ratio.
Okay.
X over 800 equals 1400 over 700.
Correct. The key was comparing that side.
I don't have my calculator.
Hold on. This side is not this side.
What?
These are similar triangles, but my bad. Yeah, no, you're right. When we flop and put it over, it is. So x has to be 1600. Yeah. All right.
Wait, I didn't do the math fully. I was about to go grab my calculator, and then I realized we're not on a calculator.
Yeah, not yet. But I hope that we'll get a chance to do some calculator problems today also, because there's only 5 of these. At least I think we will. So here's a system of 2 equations. How do you solve that? It's the easiest way to solve it. You have 2 basic methods for solving a system of equations. You have substitution, you have elimination. Which should
elimination.
We use on this?
Elimination?
Yeah, because I can do it in one step. I can eliminate the x by doing what? What do I have to do?
How I would do it is turn the first term negative.
Okay.
And subtract.
And then add them. Okay. So I'm going to multiply by -1 for starters. Okay.
Yeah.
And now add the 2 equations. We didn't necessarily need to do that because you're allowed to subtract equations also. In other words, right. I could have subtracted this equation from this equation or vice versa, and the x's would have gone away.
Yeah, it does the same thing, really.
It's all exactly the same thing. So now add the 2 equations. What do you get?
So you get y equals 14. No, 16.
Negative 16. Got to be negative. In other words, we're adding a positive 9 and a minus 25. Make sure you remember you're adding. In other words, because you can solve systems of equations by either adding or subtracting, I'm just as practiced with subtracting them as I am adding them.
Right.
But you have to remember which one you're doing. So what's the value of x?
7.
Okay. Hold on. Yeah. Ooh, a trig problem. Since when did they include trig on the SAT? This is new.
Yeah, there was trig when I took it.
There was?
Yeah.
There's been trig on the ACT for years, but there's never been trig on the SAT until this new one. Very interesting. Okay, so one angle measures x. We'll make that the angle. The right triangle. They're saying the sine of x is 4/5. So how can I label that triangle?
Sine of x. So the left side is going to be 4 and the hypotenuse is 5.
Okay. What's this side here?
3.
What's the cosine of 90 degrees minus x? Not the cosine of x. Cosine of 90 degrees. Which angle is the cosine of 90 degrees minus x?
Cosine of 90 degrees minus x. The 4-5 angle?
Yeah. In other words, this angle and this angle are complementary, correct?
Right.
So if this one's x, this has to be 90 minus x. So that's
Okay.
90 minus x. Now what's the cosine of that angle?
4/5.
Correct. I'm actually glad to see that they put a little trig on there.
Yeah, actually a lot of it was just like about sinusoid functions and stuff.
It's
That was
very
actually on the
basic
test.
trig. It's just like the
Yeah.
ACT. The trig is trig you would learn in the first 2 weeks, pretty much.
If A
What we want is one equation with only one variable, x, and then we'll be able to solve for it.
So we need to get rid of A.
Correct.
Okay.
How can you do that?
Can you multiply the top by -2?
I could even multiply the top by 2, and then notice that
Subtract it.
if you, well, no, you're not even that. In other words, usually I use elimination when they're in standard format, but this doesn't require elimination. In other words, if I have 2a equals that number, and 2a
That's
equals
10.
this number,
Okay, yeah.
then I'm going to set that number equal to this number. And
Which means that x is
I've
10.
eliminated the a. The other way, that's actually a little bit easier, does not require any out-of-the-box thinking at all, is let's just substitute. Let's use substitution. I'm going to substitute 5√2 for a. So now I'm going to write this as 2 times 5√2 equals square root of 2x, which gets us to the same place, and it doesn't require that extra thought process. Although that's not a bad one to remember, is that if you have y equals some function and y equals another function, you can always set those two functions equal to one another, getting rid of the y.
Okay.
How do I solve this?
Divide by the square root of 2?
That's square root of 2x on the right side. So I could do that, but I would have to first do this. In other words, right?
Right.
Now I can divide by square root of 2. And now what? If 10 equals square root of x, how do you get x?
Square.
Both sides.
Yeah.
X equals 100. All right, so that was the end of the non-calculator. Now, let's see what their calculator questions look like. Ooh, 38 questions, first of all. So there's a lot more calculator questions than there are non-calculator.
What?
There's 38 calculator questions.
Yeah.
Compared to only 20 non-calculator questions.
Okay.
All right, let's look at one.
Job runs at a different. Between 40 and 60.
I'm confused. Between 40 and 60, it's strictly increasing, it's then strictly decreasing, it's then strictly increasing, and then it's flat.
No.
Oh, I was looking at that whole interval. I was being fooled by the graphics. You were not. Very good. Seeing that 40 to 60 was that point to that point. Yeah.
Yeah.
All right. Cool. Let's go down to 2.
If y equal to.
This is a very standard direct or inverse relationship. First of all, what is that relationship? Is it direct or inverse?
Direct.
Correct. And you always solve these by solving for what? K. In other words, this is the general equation for a direct relationship, which is all that this thing says. But then they say that, well, when y is 24, when x is 6, that's going to let you solve for k.
Okay.
So let's do it. I'm going to substitute 24 for y, 6 for x, k equals 4. Now we have a specific equation for this model, and this is it. So now what's the value of y when x equals 5?
20.
Yeah. Now tell me, why is this in the calculator section?
Because they want you to use the calculator.
I don't know.
They want you to waste your time.
Maybe thinking about it. Why should I be using my calculator on this? All right. They love parallel lines and transversals.
Invigorable. It's 145.
Yeah. important things with parallel lines and transversals is that you only create two angles. You create an acute angle and an obtuse angle. And every other angle you see in this picture is one of those two angles.
Right.
So that one's 2, and so forth and so on. That one's 1, that one's 2, that one's 1.
Yeah.
The toughest thing about their questions on parallel lines and transversals is they usually stick in another line that confuses the transversal. In other words, if they would just draw two parallel lines and a transversal, it'd be easy. That one was pretty easy, but the ones that are tough. Tell me how to write this equation on number 4.
So 16 plus x
Plus 4x.
plus 4x is greater than.
It's 10 more than 14.
So,
This is an equal sign. Whenever you're translating a word problem and you see is, it usually means equal.
okay.
What's it equal to?
10.
What's 10 more than 14?
24.
Yep. Good thing you had a calculator there also, huh? 4x is equal to 8. What's 8x equal to? Yeah, 4x is equal to 8. What is 8x equal to?
Where do you see that?
Can you see that right there? In other words, I solved that equation for 4x.
Oh, okay.
Okay.
I was like, where are you pulling that from?
Now you could solve it for x and then answer the question, but that's actually an extra step. You don't need to. If 4x is equal to 8, 8x has got to be double 8. Since 8x is twice 4x.
Right.
All right. In general, these problems...
X is 2, 8x is 16.
Yes, exactly. You could do it either way.
D.
Well, that's a good question. C shows a very strong positive association. And A, I would say, shows a negative association, but it wouldn't be strong. Whereas D, if I were to fit a curve through D, it wouldn't be a straight line. It would be something that looks like a parabola, like that. But even still, that's a strong negative association.
Right. So 1. So 20 times 1,000. So it's 20,000.
Okay, good.
So these should be in the non-calculator section.
Yeah, I know. So far we haven't seen one yet that needed to be in the calculator section. Number 7.
a number in thousands.
So A would have 9,000 installations, B would have 5. Yeah, if you add them all up, you get 27.5, I guess. For some reason, when I was trying to do this quickly, I was estimating an average of 6, but that would be 6,000. Oh, times 5 would give you that number. Okay, that's where I went wrong. Forgot to multiply it by 5. Okay.
There's no such value then.
Good, since that's always positive.
Right.
Number 9. And number 9 refers to this up here also.
Right. Which of the following? It's A?
Yeah.
No, it's B. Oh, no, it's A.
You're right, it's A. In other words, this is easier than it looks, is all you're doing is solving this equation for t.
Right.
So you're subtracting 1052, and then you're dividing by 1.08, and that's A. Okay, let me write that equation down. We got A equals 1052 plus 1.08t, and then we have a question below it. Which of the following air temperatures will the speed of sound wave be closest to 1,000 feet per second? Finally, a calculator problem.
Yeah.
How can you do this problem?
Yeah, I mean, you could just plug in values.
It's a great problem for that. Although, notice that because we have the answer to the previous question, in other words, we solved for t, right?
Right.
On the previous question, t was equal to a minus 1052 divided by 1.08. Well, let's just plug in 1,000 for a and see what our answer is. So it's minus 52 divided by 1.08. Has to be which answer? You might need your calculator on this one. No, that's 49, I'll bet.
It's 48.1.
Is it? Okay.
Yeah.
So this was a good calculator problem. Only because they put all their answers so close together, which is unusual.
Okay.
That's, at least it's very unusual for ACT. Boy, they're giving us a lot of problems with bar charts and histograms. About number 11.
11. Which of the following is not a solution to this? Well,
We could again back solve, but it's probably going to be harder than to just simply solve it.
right.
What's the solution to that inequality?
Plus 5.
So if I leave everything on the side, I get this, right? Now, it's important to know that when you get an answer like that, and you want the x to be on the left side, you got to switch the direction. In other words, those two things mean the same thing.
Okay. Yeah.
Wow, did I make a mistake? Seems
Yeah,
like
where did you get -2?
Well, I added 3 to both sides. In other words, I subtracted 3x from both sides. Then I added 3 to both sides. Get -2 is greater than or equal to x, so x is less than -2. And yet there are two answers that, oh, no, that's the correct answer. I was being fooled by what I was looking at. What's not a solution if this is the solution to the inequality?
-1.
Yeah. See, I was first looking at it, and I was thinking that -1 and -2 were both solutions, and -3 and -5 were outside the solution. But
no,
you got to look on the number chart. There's 0. There's -2. -1 is not a solution. Number of seeds in each of 12 apples.
Okay. Based on this. One second. Okay. Well, you could plug into your calculator, or do it by hand. It really doesn't matter. But if you know the number of seeds, the number of apples, which is,
well, it's trivial. It looks trivial, but let's just get it started, and then I'll know you're doing it right. Because it's not as obvious as it would seem. What are we going to add up?
I was going to multiply and get out the number of apples. So
well,
that
12 apples.
Okay, 12 apples.
2 apples that have 3 seeds. There's 5 apples, or there's 4 apples that have 5 seeds, and so forth and so on. So what's the total number of seeds? We know there's 12 apples. If we can figure out total number of seeds, we just divide it, and that'll be the answer. Right?
Total number of seeds.
Yeah. So how
But
many?
that's not what it. What is it asking?
One seed.
Oh, yeah, okay, yeah.
Number of seeds per apple. So what, if we can get the total number of seeds, we know there's 12 apples.
So you got 3 times 2, which is 6, plus 5 times 4, which is 20, plus 6 times 1, which is 6, plus 14, plus 27.
All
okay, so
divided
73.
by
12. So there's 6. It's rounded, but there's 6.
Yeah, you're right. Okay. All right. I'll make a note that we got through number 12.
Okay.
And we can pick up next time.
Okay.
All right, Max. Talk to you later.
All right, bye.